Hi everyone. In this video, I'm going to explain about one of the classical problem of synchronization, that is reader-writer problem. In my previous video, we have discussed about producer-consumer problem, also called as bounded buffer problem. Okay, so this producer-consumer problem, reader-writer problem, and one more problem is there called dining philosopher problem. All these three are the classical problems for synchronization. So these synchronization problem we need to solve. And in the last video we saw how the synchronization problem, one of the synchronization problem called producer consumer problem, is overcome by using the semaphore concepts. Okay, now in this video we are going to discuss one more synchronization problem. There is a classical problem called reader-writer problem. Okay, here what do you mean by reader-writer? So this is the name we have given to some process. Okay, so especially what type of process? Cooperative process. See, the problem whenever we want, any cooperative process wants to enter into the critical section, we know that we should allow only one process at a time to enter into the critical section. So this is the general structure of any cooperative process. Any cooperative process wants to share the shared resource. If want to, let me suppose some resource. Okay, that resource may be a database, it may be some data variable, it may be a file, it may be some IO device, whatever. Okay, but some resources is going to be shared among the multiple cooperative processes. But when multiple cooperative process wants to access the same shared resource, so that leads to a what? Data inconsistency. So to avoid that, we should allow only one process to enter into the critical section. So for the general structure of any cooperative process, whichever the process which want to enter into the critical section, first it has to check in the entry section if somebody already is there or not. For that we write some entry section. If nobody are there in the critical section, it will allow. Otherwise that process has to wait. Okay, so once it does the critical section job, it has to come outside this exit section, informing no one are there. So then the remainder section of the program that we already discussed in the previous video. This is the general structure. Now now what do you mean by reader-writer process? So these are the cooperative process. Okay, so assume one cooperative process, that means running program. That running program, say already told I am having some shared resource. Some shared resource. This resource is going to share with multiple processes. There are some processes are there that will simply read the data, simply to take the data. Okay, they are not going to modify the data, they are not going to change the data. That means there is no harm to our shared data. This shared data is going to just read by some process. So such a type of process we call it as a reader process. So in simple words, a reader process is a cooperative process which will only read the data, which will never changes or which will never update, which will never modify the data. So there is no harm. Okay, so when already one reader process is reading the shared data, so we can allow other readers also. Because when other readers see, we cannot make many reader process to wait as one reader is already reading. Assume in this shared resource already reader 1 is reading. Now assume at the same time, suppose another reader comes, we should not make another process to wait. We can allow him because both are reading, both are not changing the data. We can allow multiple reader to read the data concurrently. See, what is the advantage if we allow multiple reader process to enter into the critical section? They can do their job easily, they can complete their operation. If they complete their operation, they can complete the entire process will get complete. Okay, so throughput will be increases and the degree of concurrency will be high. Okay, so for that process, for that reasons, we can allow multiple readers can read the same shared data. So this is called reader priority. But when assume already some readers are there, can we allow writer? No. When reader is already reading, we should block what? Writer process. That means when already some reader is reading, already reader is in the critical section, we should not allow another writer process. Okay, what do you mean by writer process? Again, writer process is a cooperative process which is going to write something. That means which is going to change the data, which is going to update the data, it's going to modify the data. Since writer is going to change the data, we should give exclusive access to the writer. That means when any writer process is in the critical section, we should not allow any other reader or writer. So that means we should block both reader and the writer. Both we should block. That means when already a writer process is in the critical section or in the shared data, so now we should not allow other reader also. Why? What is the problem? It can read, right? But if already writer is writing and another reader comes, so it is still writing, it can read, but it can read the old data only. Okay, that never get the updated data, but always we want updated data, that will be the correct data. So when a writer process is already in the critical section, we should not allow other readers and as well as writers. So we should give exclusive access to writer. So this is what the reader-writer problem. To solve this reader-writer problem means when reader is there, we should block writer, we can allow. But when writer is in the critical section, block both. So this problem can be solved by using the semaphore concepts. Okay. So here we are using 3 semaphores. One is mutex, another one is read count, and another one is WRT, right? Initially, mutex is equal to 1, indicates nobody are there in the critical section. Critical section is free. 1 means indicates what? Critical section is free, or in this case, it is used to block read count. To block read count, okay? To block the read count, so I can say we are using this read mutex to what? To block read count. I will tell why this. Okay. Now read count, initially it is 0. Initially it is 0, indicates nobody are reading. That is, no reader process is reading. Okay. And initially WRT is equal to 1 means there are no writer process is writing. That means no writer is writing, indicates no writer is writing. This is what my initially. Okay. Now let us see how to implement entry section, exit section in the case of reader-writer problem. First, simple, I will write what? Writer process. Okay, writer process, very simple. Do some code, what? See, whenever writer wants to enter into the critical section, it wants exclusive access. It wants exclusive access means it should not allow anyone. I am using only this WRT. This WRT is only for the writer process. Whenever writer process wants to enter, it should get that exclusive access through this lock semaphore. Okay. So what it will do? It will call wait WRT. That's it. Once it gets WRT, then easily it can enter into the critical section, that is our shared resource. Now it can enter. Okay, after writing, it comes out and it has to give chance to some other writers. So it has to release this lock. So signal. Okay, signal WRT. Now that's it. Do while to true. So this is just a writer process. Okay. Now assume right now in my critical section, no one are there. Critical section is free. Critical section is free. At that time, now assume one writer wants to come. Again, all these 3 are the semaphores, can be accessed only by the 2 atomic operation, wait and signal. Only these 2 are the atomic functions. Okay, wait is just to decrement and signal is to increment. That's it, simple. Okay, now whenever a writer process, assume W1 writer 1 wants to enter into the critical section. It will first check wait WRT. What is our WRT initially? It is 1. So WRT is equal to 1. So it takes 1. So it will call this function, goes here, wait 1. Yes, receives 1. 1 less than equal to 0, false. Comes out of the while loop, decrement. Now S becomes what? Yes, now S becomes 1, WRT. So this becomes 0. So that means now one writer is writing. Initially 1, no writer is writing. Now it is 0, means writer is writing. Now it comes and comes out of this function, comes to the next line. Now it enters in the critical section. Now W1 is in the critical section. W1 is it. Now assume while the writer 1 is writing, assume after some time another writer comes. When other writer comes, again we'll check. Wait WRT. WRT is 0. Again 0 less than or equal to 0, true. Come inside while loop, do nothing. Again goes 0 less than or equal to 0, true. Again comes inside, do nothing. It keeps stuck here. Okay, it never comes out of the while loop. That means it is waiting for this writer to come out. So this is how the exclusion is. That means when one writer is writing, it is blocking all other writers. It is not allowing other writers. This is what the writer process. Okay, now let us see reader process. Okay, so now assume initial value. I will go back to initial value. WRT is equal to 1 initially. So now I am writing reader process do. Now in reader, while reader is reading the value, reading the content from the shared resource, that is critical section, can it block reader? No, it cannot block reader. But when any one process wants to read, where that reader process can allow other readers, that also no. See, for example, whenever we want to assume a train or bus, okay, tickets, okay, or taking the seats, assume there is no online booking, okay, we are not booked. So, okay, it's a holiday season, too much of crowd is there. So now what happens, suppose what you will do, generally, all we want to enter inside the bus or train to grab the seat first. When we are, see, still we are not get the seat, but when we are rushing inside the bus or train, whether we are giving some space or room for other passengers to get the seat, no. Once we want to get inside, after getting our seat, then we can give seat to others. In the same way, whenever a reader process wants to enter into the critical section, by the time, for the short period of time, by the time it enters into the critical section, it has to block other readers. Okay, so like how we are entering into the train or bus, we are blocking the way for others, and we will somehow get into the train or bus to grab the seat. In the same way, so now reader process, whenever it wants to enter into the critical section, it will block other readers. Okay, so for that one more variable called read count. This read count indicates how many readers are already reading in the critical section. Already how many readers are there? For that read count, as the name itself will to count how many readers are there already in critical section. But to block these readers, we are using mutex. That's what to block this read count. To block other readers, okay, we are using mutex. Okay, so now first, assume now reader, assume I am the reader. So whenever I want to get into the critical section, can I leave others? No, along with me, no, I have to block. For the block, what I have to do, I have to use first mutex. Okay, so wait, mutex. Okay, wait mutex. That means right now, mutex is equal to what? 1. It goes 1. 1 less than equal to 0, false comes out, it makes 0. Now it is done 0. Okay, now it blocked, I blocked another. Okay, now after mutex, now what? I am the first person entering. So how many processes are reading? I am the only one person. That means I have to increment the read count. So increment read count. Read count plus plus. That means now I incremented this as 1. That means now one reader is reading now. One reader is about to read. But once I get into that, okay, now I am reading, I can allow other readers. Okay, so but when I entered, can I allow writer to write? No, I should block writer. That's what reader has to block writer. To block writer, it has to acquire this. Okay, so for that, if I check, if read count is equal to 1. That means what? See, if I am the first person to enter into the critical section and reading, I should block. Suppose if second, third, I am the third reader or the fourth reader or the second reader, no need to block because already the first person who already blocked the writer. That means whoever who enter into the critical section, the reader, whichever the reader process which enter into the critical section first, they have to block the writer. So first reader has to block. That's what I'm checking. If read count is equal to 1, that means if this is the reader process, the first reader process enters into the critical section, it has to block. It has to block means what? It has to decrement this one. Decrement means what? Again you call wait. Wait WRT. Now I made this also as 0. That means I blocked. Okay, I block the reader. After blocking the write, now I block the reader, I block the writer. Now I got the seed, now I have to leave other, I give chance to other. So now I have to make sure other readers also come now, because we should not block readers in the reader priority. So now I have to allow. For that, what I have to do? I will do signal what? Mutex. Now I am not blocking the reader. Now again I am bringing this back to 1. Okay, increment. Signal means 0, 0 plus plus 1, I did 1. Now after that, now I will enter into the critical section now. Who will enter? Now I said I am the reader 1. Now reader 1 enters into the critical section. Now reader 1 is executing the critical section. Now let us take now one more reader can allow. Assume at the same time now one more reader wants to come into the R2. Can we allow? Let us check. Now again to check. Wait mutex. Mutex is 1. Yes. Take this mutex value 1. Wait 1. Yes, this is 1. 1 less than or equal to 0. False. Comes out. Make it 0. Make it 0. Make it 0. Comes out of the white. Comes out of this one. This one. Now read count is what? That means now already this one is reading. Now this is the second person to read. Read count is what to 2 now. Check. Read count is what to 1. No, this is on the second person. Already the first person already is blocked. Okay. Now condition false comes out. Signal mutex. So again see mutex is 0. 0 plus plus 1. So it becomes 1. So I make it as 1. Now that means now R2 also enters. Now both are there. See, it is not blocking reader. So reader is not blocking reader itself. Reader is blocking only what? Reader is blocking only the writer. Assume now these two readers are there. Assume now, right now, assume W1 wants to enter. Writer 1 wants to enter. Now writer 1 wants to enter. Say wait WRT. WRT is 0. 0 goes here. 0 less than or equal to 0. True. Come inside. Do nothing. Again goes condition, do nothing. It keeps stuck here, keeps checking here. It never comes out of the while loop. It never comes out of the while loop means it is never coming out of this function. It is not coming out of the section means this is not coming out of this statement. That means it is blocked. That means when reader is already in the critical section, it is blocked what writer. We solved one problem. Okay, assume, but it not blocked reader because two readers, similarly a third reader also. Assume after some time, readers wants to go out. Okay, assume or one reader completes his job. After going, what it has to do? Now it has to, well, again you block other because when I'm going out also, I want to go first. I'm not allowing other. Okay, so I want to what block. So again I will make wait mutex. Okay, so then again I made it 0. I blocked other readers to go out. Because I want to go first. Okay. After wait mutex. Now earlier 2. Now 1 is going. That means read count should be decremented. So read count decremented. Now this becomes okay 2 earlier. Now it is 1 now. Read count becomes 1. After read count 1, see, I have to check. The last person, if the no readers are there, now we can leave chance to what? Right, because only writer is waiting. Okay, so now I have to block that. If I the last one, so if read count is equal to 0. Okay, I'm checking whether the last reader going out, if the last person is going out, they has to give the chance to a writer now because nobody are there. Now let writer comes in. Okay, so I'm checking now. Read count is equal to 0. No, still read count. That means still one reader is there. Out of 2, 1 is coming out. One reader is still there. So condition is false. If the condition is true, they have to release this WRT. So signal WRT. So then it comes out. Okay. After that, what you have to do? You have to release this mutex also. So signal mutex. See, I blocked here, right? That I am releasing. Okay. Now again I made it 1. Increment. Signal means it is incrementing. Okay, comes out. Okay. After that, that's it. While true. Now see, now assume one process comes out. Assume R2 comes out now. R2 comes out. Now how many processes are there in critical section? Only 1. That's why read count is equal to 1. Assume after some time this also completes reading. It wants to comes out. Now again wait mutex. Again mutex will be decremented. It will be 0. Then check. Next, read count is going to make it 0, decrement it, 0 did. Then check, read count is going to 0. Yes, read count, that means this is the last. After coming, R1 is coming out, there is no reader is there. So comes out and it will signal WRT. That is now I am making out signal WRT, so to 1. And then it comes out signal mutex. Again I am releasing this one. That means now I come out, that means now no writer, no reader is there. No reader is there. That means critical section is empty. Now it is keep checking Allah. Now it keep checking. Now but WRT now it becomes 1. 1 less than equal to 0. Condition is false. Comes out decrement. Now WRT becomes 0. Now writer enters it. See, while writer is entered, already we know it blocks the writer. Let us see now reader. Okay, now who is there in the critical section? Writer 1 is writing. Now at that time, assume reader wants to come. Do mutex. Mutex is 1, still 1, it's fine. Decrement. So mutex becomes 0. Read count. Nobody are done. Yes, reader 1 is happy. It is about to enter, not yet entered. About to enter. Read count is equal to 1. Yes. Now wait WRT. WRT is 0. Wait 0. 0 is passed here. 0 less than equal to 0. True comes inside. Do nothing. Okay, again condition goes. Again condition true comes inside. Do nothing. Again goes. Now this reader is stuck in the while loop. Stuck in the while loop means it is not coming out of this function. That means it is not coming out of this one. They are stuck here only. That means reader is also blocked. This is how when already writer is there inside, so it blocks both reader and writer. But when already reader is there, it should blocking only writer. We saw both the instances. Okay. So this is the one of the classical problem. And you people, I hope you people understood the concept. Okay. If you have any questions, please write it in the comments. Thank you. Thanks for watching.